Geophysical technologies are going to play a crucial role to meet the world's increasing demand for energy in the decades to come. A lot more hydrocarbons will be needed because the world's population is growing so fast. Having access to large new resources of oil and gas will buy us time to make the transition to renewable energy sources. The challenge we geophysicists are faced with is that in the pursuit of these large new resources, we are looking for more and more difficult to find hydrocarbons. These might be buried several kilometers in the ground, hidden under complex geological formations such as salt, located under ice shields in the Arctic, or just captured in small accumulations that are simply difficult to detect. Of all the international oil companies, Shell probably has the strongest overall reputation in geophysics. We are definitely in the forefront of using one of the main tools of geophysics, namely seismic imaging. Seismic imaging plays an essential role in finding oil and gas deposits. We measure sound waves bouncing off potentially hydrocarbon-bearing rocks, which we then use to compute an image of these rock layers below the ground or under the sea bottom. Salt layers form a shield that interferes with seismic waves, so that we cannot see the underlying formations. A promising novel seismic technique today enables us to illuminate below these seismic shields. Unfortunately, the technique is not cheap, as it involves placing hundreds of sensors on the seafloor. Therefore, we are currently only using it on a small scale. But already it has dramatically increased the probability of finding hydrocarbons, for example in the Gulf of Mexico, where this picture is taken, sometimes literally leading to billions of dollars of value from the hundreds of millions of barrels of oil we have discovered. To deploy this measurement technique on a larger scale, costs need to be reduced, while its quality and robustness may need to be further improved. This would allow us to make more precise measurements more often. This seems an almost impossible task, and it poses a significant challenge to the R&D community. In Shell, we are convinced that by working with partners, sometimes outside our industry, we can develop innovative concepts that meet this challenge. Such unusual R&D alliances have proven to be rich sources of innovation for us. One example is our collaboration with Hewlett-Packard. In this project, we are developing a wireless sensing network that could potentially revolutionize the way we gather seismic data. Someday, this technology may allow us to cost-effectively collect up to 2 orders of magnitude of more seismic data that is more precise, more robust, and can be taken more frequently. This then would immediately pose another challenge. How do we process and manage all that data? This creates significant R&D challenges to the computing industry, which is why such alliances are perhaps not so unusual. We are pretty much driven into each other's arms. What really motivates us to team up with these important players and form R&D partnerships is to bring in more new ideas and quickly test them for applicability to solve our challenges. For geophysics, that is paramount. The computing, medical and defense industries, and even Hollywood are becoming relevant to helping us solve our geophysical problems. For example, the development of large-scale MRI and ultrasound imaging techniques in the medical sciences have led to interesting concepts that are also relevant in geophysics. Similarly, the computer rendering and animation used to create 3D movies may help us to visualize large amounts of seismic data. In other words, we can learn something from how DreamWorks made Avatar. In fact, the pace of innovation has dramatically accelerated and is now more driven by market demands. This means we need to be pretty flexible and willing to cooperate with new and sometimes unexpected partners and on much more accelerated timeframes. Of course, it is one thing to increase the number of ideas by partnering, but to be effective, you also need to cull ideas. Culling early is very important. I used to say, the best researcher is the one that fails fast. You have to be able to let go and learn at the same time. You may think there is a geophysicist in an attic working out a single solution that could revolutionize the business. In reality, it's a very diverse effort. Not just a research effort, but often the ideas are initiated on the business side. Bringing these ideas to full maturity for innovation to be effective requires a clear line of sight and linking the research and business teams in an ongoing working relationship. As the chief scientist for geophysics in Shell, It is very gratifying and very exciting for me to help create that vision and provide the space and the energy for people to work together and get aligned. These are exciting times, as much more is possible today than just a few years ago. To make full use of emerging opportunities requires courage, technical intuition, combined with a good business sense and an entrepreneurial attitude. I'm excited to see more and more of these qualities appearing in the technology groups here in Shell. It is these qualities, innovation spirit and drive of our people, that make me confident that in 2 or 3 years Shell will be clearly ahead in getting business value from new geophysical technologies.